now begin our next section by Dr. Kedar Kulkarni. He has done his PhD in Applied Economics from Oregon State University in 2021. His interests lie in at the nexus of agricultural economics, environmental economics, and development economics. In particular, his work focuses on sustainability of agriculture systems in developing countries, including climate change impacts, adaptation, and mitigation in agriculture, and on examining the environmental impacts of agriculture technologies. So, the courses that Dr. Kedar engages are Applied Econometrics with Strata, Economics of Climate Change, Introduction to Statistics and Programming, and in his free time, he enjoys watching football and cricket, playing chess and traveling. So over to you, Dr. Kedar. The platform is all yours.
Thank you, Ranjan. Yeah, it's a pleasure to be here to interact with everyone, and I'm really thankful for inviting me to present on the climate change economics. It has been an area of interest for me for the last few years, and hopefully I make it interesting for everyone. Sherry, I just wanted to ask Dr. Ranjan, are we taking questions as we go, or are the questions there?
Questions will be at the end, not during the presentation. So you will have an uninterrupted time of about 45-50 minutes, and followed by a 10 minutes of question answer.
Great, thank you. Yeah. So my agenda for today is basically to talk on 4 topics. So I wanted to actually start with the science of climate change. That is, how do we really look at climate change from a very academic as well as scientific perspective. Thank you. Then I'll delve into the economics of climate change, starting with the macroeconomics, the global picture about how climate change came to be a discipline within the economics area. Then talk about the interactions between countries and within countries and the impacts of climate change. I'll look at the impacts of climate change, focusing on only 2 sectors for now, although it has very diverse impacts. I hope that in the other talks that have been scheduled, some of this they are going to be discussed in more detail. So I've limited this to just a few sectors. And finally, I will end with the possible solutions from an economic perspective. That is, what are the tools that we as economists think we as economics think are useful for policy making, as well as for actually being the realistic solution to tackling this problem we face. So I'll start with the science of climate change. Maybe it's important to start with the distinction between 2 things. One is, first of all, how do we understand climate change? That is, what is the scientific basis for this? And secondly, if we do have a proper understanding of what climate change should look like, do we actually see this in the real world out there? So is there enough evidence for it? To begin with, I think let's distinguish between 2 things. One is what we call as weather, and the other is climate. So oftentimes it's very intertwined or used interchangeably, but I think this distinction is really important when we talk about climate change. So when we look at weather, for example, we are essentially talking about short-term changes in the atmosphere. So the daily variation in temperature, in the morning it was 20 degrees today, right now it is about 25, in the afternoon it was 28. These short-term changes are basically referring to weather. Climate, on the other hand, is more of a longer period change. That is, when you continue to observe these short-term changes in weather over a really large period of time. So if I'm going to be observing the weather in Bangalore for the last 30 years, and I see that, okay, there are changes over a large period of time, then I could say that, yes, there is a change in the climate. So climate is defined as some kind of a statistic that is observed over a large period of time. The rule of thumb is anywhere around 20 to 30 years. And if you see these large period time changes happening over a particular space, then yeah, you can say that that particular region is going through a climatic change. a very simple way or intuitive way to put this is that climate is an expectation. It is what we expect, and weather is the realization. That is what you get. Uh, so given this, here's an interesting graph that shows the changes in temperature in the last 70 years. On the left hand side of the figure, I have the temperature change annually for India, and you can see that within the country there is a lot of variation. So northern regions are much more colder than southern regions as expected. But if you see temporally, that is over a period of time from 1950 to 2010, you can see that temperatures are rising, and this is one evidence that scientists present as corresponding to a change in climate. That is, there is a change in climate, temperatures are rising. Now, the word they have been using for some time is global warming, but currently we are going to stick with climate change because you can also have periods of really cold weather over a period of time, and that really does not mean there is global warming. So in this case, all we are referring to is temperature increase from a particular period of time somewhere back in 50s to right now 2010. And you can see that many of the states in the southern region are actually experiencing hotter temperatures. In the west, for example, Rajasthan is a really good case here where it has increased a really high increase in temperature. And you can see that from about 21 to 23 degrees, it has gone to something around 27 degrees on average. Right? That's a really big change. Globally, the way we see it is you put a benchmark. So in this case, the benchmark is starting the period of industrial revolution, so the early 1800s. And what was the temperature around then, the average temperature in that period, and how was the current temperature changed relative to that? So if you put that and you put that on a graph, you see something of this curve where in the last 100 years, temperatures have only begun to increase. Right? You don't really see a drop in the last 100 years, for example, starting 1920 or 1930. And this is again more evidence towards the fact that we are seeing rising temperatures and climatic change, and the realizations of this can be manifold. For example, one realization is increase in droughts or more periods of sustained heat, increase in natural disasters like floods and landslides and so on. And so I think this is the context I wanted to start with, because on one hand you have experiences in natural changes in the climate, but automatically the second question that comes is why is this happening? Is there a basis for these changes, or is it purely natural? And as economists, we always try to link any natural phenomena to something human related. And so I'm going to introduce the term anthropogenic climate change, that is a human and if there is a basis to be made for this, is there evidence for that? So for instance, if you look at the carbon emissions, that is the emissions that are mostly coming out from the burning of fossil fuels, it's around the same period of time, that is around late 1900s and early 1900s, you see a clear jump. And this is what's called the hockey stick debate, because if you look at the graph, it resembles like a hockey stick, right? Very flat at the initial stages, but then there's a clear jump. And I wanted to resemble this graph to the one that I just showed here, where if you look at the jump after 1900, it's more or less similar to the jump that is being seen here, right? And this is one evidence or some kind of sufficient data that we have to argue that the climate change that has been observed in the last 100 years is very likely due to human-led activities, for example, burning of fossil fuels. Now, how does this happen? Like, if there is a linkage, then what are the key channels through which this might happen? So this is a nice feedback loop that has been developed by some authors. What you have is land use change. That is, you have some changes in human-led activities. For example, you buy more petrol, transportation changes, and so on, which also you can have more construction, which results in large amount of CO2 emissions. It It is transferred to the atmosphere. You have radiative forcing, that is change in the energy balance. It results in changes in temperatures, and this changes in temperatures has again it impacts on the physical climate, that physical changes that we are observing in the climate. So, for example, this could be the rise in global surface temperatures, or rise in sea level changes, or changes in rainfall variability and seasonality. A lot of evidence right now exists when it comes to, for example, agriculture, where we are observing not only large periods of drought, but also we are observing that the rainfall pattern itself has changed. And one indication is that we see many agricultural farmers talking about switching the cropping season, or shifting the cropping season by a few days or weeks as well. Right. Obviously, all these things have impacts on the physical human systems. I'm going to talk about this a little in detail later, but right now, what I would like to make the point is that these human-led activities result in really large amount of CO2 emissions, which has in turn caused a change in climate, and that change in climate is affecting us. Uh, 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 right. Now, if the corresponding statistic, what we notice is that the CO2 concentrations have increased from 280 parts per million to 380 parts per million. Parts per million being a unit of measuring the concentrations. And most of this is due to deforestation, changes in land use, and fossil fuel burning, as argued. This is what's called as the greenhouse effect. Now, having presented the core idea of what climate change is and why it is essentially an economic problem, I wanted to delve into the historical reasons for this, as well as various within countries, for what might be the reasons for the human-led climate change. So, if you look at this figure, it's from the IPCC report, the working group report that came out 2 years back. There is a clear jump in the GHG, or the greenhouse gas emissions. And if you look at it by the components of what emissions have increased, the CH4, the methane emissions, CO2 emissions, but the very large percentage of it comes from CO2 from fossil fuel and industry. Right? So one obvious fact from this is that the industrial growth that has been basically been channeled by the growth in the UK and the West, starting with the industrial revolution, has resulted in the increase in CO2 emissions. Now, moving ahead, if you look at it by sector, that is, which sector is actually responsible for the GHG emissions, you will find that overwhelmingly this is coming from the energy sector. That is, the energy used in industry, transportation, the buildings, and other households and so on. Right? And this is about 74%. Right? So these 74% of emissions that are generated because purely from energy sources, again goes back to the point of fossil fuel burning and other related sources, as I said. Right? Very few percentage of emissions comes from agriculture and chemicals industry and waste. Right? So this has direct implications for the solutions, because if one were to look at this figure, it is obvious that the intervention has to come into the energy sector as well. Right? And that's where currently most of the energy and most of the innovations and inventions are happening, because that's also one of the sector that's responsible for the current CO2 emissions. If you look at it by within sector, right, electricity and heat obviously captures the most emissions in the past 30 years. Right? Transportation is very less, and manufacturing also very less. Right? So again, the implications are very clear that if you want to solve this problem, the intervention has to happen in the sector of transportation and electricity and heat. And if you were to look around you and see where exactly the new EV vehicles or the electronic innovations are coming, it's in these two sectors. Right. Now, so if we go into the more historical context, that is, in the past 150 years, we have noticed a really large influx of CO2 emissions. The question then comes, who is responsible for this? That is, where do these emissions come from? And we know which sectors these come from, but do we also know geographically which nations are responsible for this? And it has really accounted for a very important role in the climate policy debate, because on one hand you have the developing countries that want to grow and reach the standards that developed countries have currently developed. But you also have the notion of climate change, where you want countries to be developing in a more sustainable way, that is, reduce this carbon emissions or carbon footprint while increasing the GDP. But if you look at it historically, this has not really been the case. So, for instance, uh, this graph, which talks about the cumulative emissions, that is, if you were to aggregate the total number of emissions starting 1850 until last few years, you'll see that US and China account for the majority of them. US by far leads in this race, and most of this is coming from fossil fuels. India has definitely been in the top 10 countries, but that has only been because of the growth we have achieved in the last 30-40 years. But if the top 15 countries tend to be the ones that are the current Western bloc or the most developed countries: United States, Germany, UK, Canada, France, right, Australia. These are the countries that have really been historically accounting for the most CO2 emissions. But then the question is, should we actually look at the total emissions? Because countries differ by many things. One is obviously populations are different, and every individual living has a carbon footprint. So when you are aggregating all of this, then it does come to the fact that for India and China, we are about 1 billion and more people. We'll definitely have more emissions. Should we look at carbon emissions just as a whole, or should we look at it from a more weighted perspective? Right? The other question is, you have also seen changes in production processes as well as trade. That is, now you have countries where they can actually set up their base in another country and still import those goods. Now, the problem is, if, for example, US sets up its base in a third world country like Indonesia or India, the emissions that are going to come out of those factories will be accounted in the favor of India and not US. But to be very clear, these are factories or companies owned by the US. And so the country that's actually should be responsible for these emissions is the US and not India in this case. Right? But the current accounting works in such a way that wherever you are producing that particular good, that country is responsible for it. So if you were to actually control for these things, that is, if you take into account the imported CO2 as well as the exported CO2, you'll see that it doesn't matter much, right? China, in fact, is one of those countries that is responsible for a lot of more exporting CO2 than importing, right? United States, on the other hand, imports a lot of CO2. And so if this argument really falls flat, that is, if the countries are setting base in other countries and therefore you need to take into account, you still see that the historically the countries that have been responsible for CO2 emissions are more or less the same. But things change when you look at the per capita emissions. That is, if you have to control for the population, and then you see that India and China are nowhere close to the top 10 countries that we find in the other chart. That is US, Canada, South Africa, European Union, UK. And in fact, India is much, much below the global world average. Right? And that's one of the cases that India has been making in the last few years, is that historically we are not responsible for the current situation. That is, the climate change that we are realizing today is actually a cause by the countries' growth in the early 19th century. That is US, UK, and so on. And so our targets are very different from the targets that United States or UK would have. But I wanted to present these pictures to set the context that the situation is not that easy at the global level, because different countries have different way of looking at it. So if US wants to, for example, provide a solution to this, they would argue that cumulatively the top 10 countries are us, India, and so on. So all these 10 countries should have a say in climate policy. Whereas that is they need to start reducing their footprint. Whereas India would argue the other way around, that we still need to achieve a certain standard of living, and therefore for us it's important to grow, and the current cheaper solutions are fossil fuels and so on, right? Until and unless the alternative solutions are developed, we cannot really move towards that. Now, this has been a case where I have presented the spatial distribution of carbon emissions across the globe. But if you look at it also from an individual perspective, that is, if you look at how humans have individually contributed to this, you will see that there is still an inequality present there. What do I mean by that? That is, if you were to take the bottom 50% of the world population, bottom 50% in the income distribution, you will see that they are responsible for only 12% of the total global emissions in the year 2019. Whereas the top 10%, that is the top 10% in the income distribution, or you can also equivalently say the top 10 richest percent of the entire globe, they are responsible for almost 50% of the total emission, right? 48% in this case. So this inequality is much more stark, because what's really happening is you have the poorer population who is really not responsible for climate change. That is, they do not have a large carbon footprint, but they face the most stress from climate change, right? Because their resources to adapt or mitigate are less. Whereas the top 10% are responsible for the most amount of carbon emissions, yet they have the best resources to tackle it, right? And this paradox is really stark because it has implications for policy. So this graph here basically presents the argument I presented earlier, which is the top 1% is responsible for 17%, top 10% is responsible for 48%, the bottom 50% is responsible for only 12% of the total emissions. So this obviously leads to the conclusion that we need to decarbonize the global economic system. That is, we really need to start reducing our carbon footprint. The question then is, how do you reduce it? And if you do want to reduce it, what should be the quantity that we as a society have a benchmark that says that, okay, I think we are now at a stable situation. The IPCC working group report presents a 1.5 to 2 degrees Celsius threshold. That is, we need to limit the warming to 1.5 to 2 degrees Celsius. Currently, we are reaching the 1.5 degrees Celsius, and this is with respect to the 1850 to 1900 threshold, right? So if I go back and I show you that graph I presented earlier, this one, you'll see that the current temperature difference is close to 0.9 degrees in 2010. Right now we are inching towards 1.3, 1.4. IPCC wants us to stop this temperature difference by 1.5 to 2 degrees Celsius for us to have minimal impact of climate change. Beyond 2 degrees Celsius, they project that we will be in a catastrophic climate change situation. That is, it will be irreversible. Okay. So, which means that you need certain solutions for this. One is that you need to decrease the carbon intensity. That is, you need to start thinking about how to decrease the energy efficiency of fossil fuels. But the other problem is that, well, yes, we can start decreasing energy, we can start decreasing carbon emissions by increasing the energy efficiency. But at the same time, we are also experiencing the rising population as well as income. Now, once this happens, more population implies there will naturally be more carbon emissions. But more income also implies that there will be higher carbon emissions, as we have seen earlier. That is, if you see that the richer people or the richer percentage of the population is responsible for the most amount of carbon emissions. So there seems to be a direct correlation between income, population, and CO2 emissions. This is the idea of relative decoupling. What is required is the opposite. That is, we want absolute decoupling. We want to reduce emissions, but we also want our incomes to grow. That is, we want GDP growth. Now, this really moves to the third part. That is, If climate change is real and it is going to impact human systems, do we have any idea of how this will happen and what are the economic impacts of this? Right, and I'm going to focus here on the two main sectors, which is the agricultural sector and the production sector. So one is that we know that there are heterogeneous impacts, that is heterogeneous in the sense that impacts are differential across the countries. So some countries are going to be more affected by climate change than others. One obvious thing from this is that large and direct effects will be seen on agricultural sector. But we also see from various studies that the effects are visible in the decline in labor productivity, that is the manufacturing sector, and therefore in the economic growth. So if you look at the agricultural sector, one obvious fact that we see from various studies is that the effects of temperature are non-linear. That is, there is a threshold or the fact that temperature will have both positive and negative effects on crop yields. The question is, at what degree Celsius will we start seeing negative effects? And that's a question for most of the agricultural researchers as well as other scientists. But what we know so far is that there will also be reduction in the effectiveness of inputs like fertilizers. There will be accelerating damage caused by pests and soil erosion. Right? And this has implication for food security, because the moment we start experiencing decline in crop yields, we will have a lot of people who will starve, or will have less food in the market. That will result in increase in prices, and therefore that will have implications for human development as well as welfare and so on. It will also have implications for environmental and ecological growth. For example, we might see loss in biodiversity and wildlife. And so I wanted to present one nice picture here that shows how temperatures might impact crop yields. This is from one of the recent papers that came on India. It looks at how temperature affects rice yields and so on. And what you can see is that beyond a certain degrees Celsius temperature, you only see negative effects, right? Until about 15 to 16 degrees Celsius, you see that temperatures will have positive effects. But beyond that, you start noticing a decline in yields as temperature increases, right? And beyond 30, it's even more. Right? And this presents us a really good case for understanding what the critical thresholds for each crop should be, right? And which crops will be grown in which areas and so on. And there are multiple studies that say that for rice, for example, anything beyond 32 degrees Celsius is really critical and will result in a total crop loss, right? The other question that's interesting is about this nice picture, and this is just a correlation. You cannot make a causation, but it does point towards the impact of temperature on economic growth. What you see is that on the y-axis you have the GDP per capita, on x-axis you have temperature, and as temperature increases, you see that GDP per capita is decreasing, which leads us to believe that yes, hotter countries are more poorer on average. But the question here is this actually true, right? That is it because of climate change that hotter countries, and for example, this might be most of the temperate countries, are they really experiencing a decline in GDP, or are there some other reasons for this? Right? In other words, do you have any evidence to show that temperature does cause decline in productivity? And that's where I wanted to come into the last part of the impacts section. What we know is that yes, it is going to have negative impacts on both physical and mental health. I'll just cite one important study here, which was conducted in a survey of lot of Indian manufacturing firms, and what they found was that the value of manufacturing plant output declines in the years with more hot days. That is, whichever years had really large number of hot period days, in those years the manufacturing plants had experienced a decline in total output. What is also predicted is that a 2.1% decrease in the output happens for every 1 degree Celsius rise. And so this is a really large effect, right? Because you are seeing really almost 2% of the total revenue or output falling for every 1 degree rise in temperature. And the main channel here is that you have workers who are experiencing a really immense amount of physical and mental heat stress, which causes decline in the productivity, and therefore that affects the manufacturing revenue. And so, given these impacts as well as the other issues that I presented, I wanted to move into the last part, which is to talk about what can we do, right? What is it that we as a society as well as policymakers can think of to tackle these problems? Now, the mitigation part is where I'm going to focus on. There are also adaptation solutions, but I believe that the other talks are going to focus more on the adaptive problems like the nature-based solutions and other small-scale solutions at the very granular level. I wanted to present more of a policy picture where, as economists and policymakers, how do nations or aggregated regions think about tackling these issues, right? So the one is obviously about decarbonization. That is, you need to control GHG emissions. The other is, which is a very radical solution, which is to sequester GHGs from atmosphere. And one possible solution here is the idea of stratospheric aerosol injection. What you're going to do is you're going to enter the atmosphere with some kind of aerosols. You're going to create a cooling effect that sequesters the emissions from there, and therefore, at least for some temporary period, you will have a cooling effect, which means that you will face lesser solar radiation and lesser increase in temperatures. Now, this is definitely a very radical solution. It hasn't really been implemented yet, but it is in the works. The more realistic solutions tend to be at the granular level, but also going to be incentivized by the countries themselves. So one is obviously at the supply side. So how do supply side industries think of this? One is that there has to be a really big reason to move away from fossil fuels for now, at least at the developed countries level, where they have the resources to move away from fossil fuels into the renewables for production. So you, for example, as I presented earlier, electricity and heat is one of the main sectors that's responsible for CO2 emissions. What we are now seeing is a transition into green innovation in these sectors. That is, you want electricity to be produced by cleaner sources. So solar, wind, geothermal, Titan systems, etc. Right? This is one area. The other is the demand side, that is from the consumer side, where you want them to incentivize or make them aware about reducing the energy usage as well as materialistic changes. So, for instance, can you improve the energy efficiency in construction or buildings? Right? Many of the Western countries rely on electricity for heating because they are really facing a lot of winter days, and they use some kind of fossil fuel burning to channel their electricity. But can they move towards more cleaner form of energy systems to create those electric grids? In the transportation, we have already seen influx of electric vehicles and some kind of hybrid system. But also the solutions are presented at the more individual level, that is at the behavioral and lifestyle level. Can you move away from using one person, one car and do carpooling, or more reliance on public transport, a better infrastructure for public transport, more water usage that is at a sustainable level, introducing smart meters that tell households about their carbon footprint, incentivizing them to reduce their carbon footprint, and so on. From a more policy perspective, the case of climate change is a classic case of market failure. That is, you have certain agents that are responsible for this, but do not compensate the affected agents for this, right? And so it's called as a global externality. There are three policy solutions here. I'm going to briefly talk about them, and some of them are already introduced, some are in the place. One is a carbon tax, that is, you want to introduce a per unit tax on each good that is responsible for CO2 emission. One obvious example, this is of petrol. So can you introduce a petrol or a gasoline tax? For every liter that you consume, you're going to pay some extra amount, which is going to be seen as the form of a carbon tax. And the idea is the revenue that the countries will get from this carbon tax will be redistributed in adaptation or mitigation policy. Right? For example, you can tax tax cars or transportations that use petrol. Use that revenue to fund renewables, or you fund fund funds that are going to do more of R&D and so on. The other is on emissions trading, which is the market that you're going to create to introduce funds to be more responsible for their emissions. So one is a simple cap and trade. What you would say is that in an industry, for example, the electricity industry, you can set a rule saying that only this many amount of CO2 is permitted. Now, the firms have to legally follow this. And if they don't abide by these conditions, what they can do is they can trade the carbon credits between themselves. So for instance, a big firm, let's say like a Reliance, can go to another firm and say that we will pay you this much, can you give us your carbon credits? That is, can you allow us to emit more and we will compensate for you for this. That's totally fine. And this system has been in place in the European Union, the ETS, or the emissions trading scheme. And while there are limitations and advantages to both, what I would like to rather emphasize is that there are these solutions that are possible to reduce carbon emissions. And the simple economic reason is that prices are an incentive for governments to act. Right? The other is obviously subsidizing clean energy technologies. So from the policy perspective, governments will have green innovation funds or renewable funds that will serve as an incentive for smaller and bigger firms to move into clean energy. You can also remove subsidies for fossil fuels. This seems like a really big task for developing countries. For instance, in India, it might create a lot of controversy if you were to say they're going to remove a coal cess or coal subsidy. But there do seem to be some kind of argument for why we need to do this, given that fossil fuels are definitely one of the main sources for carbon emissions. The last solution I would like to present here is on climate finance, and this has really taken a lot of interest in the last few years. Many individual firms as well as large-scale firms are really thinking about investments in low carbon technology innovation, right? So think of your solar, wind, solar photovoltaics, and so on, where you want some kind of innovation to come about that can present as a case for moving away from fossil fuels, as well as serving as a tool for understanding how to move into the green transition. On the individual level, at the household sector, you can think of consumption, that is, can we move towards consumption of low carbon goods or services, which means that you need to make households aware of their carbon footprint and incentivize them to move away from fossil fuel usage. The financial institutions also have a purpose to serve here. So the commercial banks as well as small scale financial providers need to come up with solutions to provide loans to firms that are actually interested as well as have solutions to fossil fuels and are interested in investing in low carbon technology. There is a new phenomena that is ESG metrics. It's a sustainable metric that many firms have begun to provide. That is how, in a very simple way, it says how green is your company, and it basically says that the higher your ESG scores, the more incentive it is for them to behave sustainability, and therefore that also creates a basis for them to require certain or as well as not require, acquire certain financial instruments. And I will probably end with this very interesting graph on how we as a global unit are moving very slowly towards the green energy transition. and that's where the real solution lies to climate change in the next few decades. If you look at it from the last 20 years, the uh, amount of money that has been invested in green energy transition is almost 100 times, or sorry, 50 times than what it was in 2004. Right? Currently, $1,769 billion are being invested in this, and most of this is coming in the form of renewable energy as well as electrified transport. And you can easily tell that if you look around in India, EV is one of the really booming markets, as well as the solar and wind energy systems, right, for green energy. And that's where really I would like to stop, and I would really appreciate any questions or any comments that you have on this. My point was to maybe give you an overview of what is going on in the field of climate change economics, where is the next big thing coming from. But I also wanted to highlight a few things about who is going to be responsible for this, who is going to pay for these things. Is there an inequality in carbon emissions within and across countries, as well as talk about a little bit on the kind of investments that we might see going forward. Thank you. That's it.
Yeah. Thank you, Dr. Kedar. We'll now open the platform to all the participants. If anybody has any questions, please raise your hands.
Uh, 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 uh,
Yeah. Yeah. If anybody's got any questions, please raise your hands.
uh, 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 uh,
Yeah. So, Kedar, my question is, who are the people, the narrative? Which narrative from which part of the countries are being pushed forward? I mean, there is a clear distinction between the developed country narrative and the developing countries. So, where does it all stand? As in, who is pushing, who's being pushed around, or who is winning an argument, or anything, or any insights on any of those?
the international politics of climate change mitigation is a completely different area. I haven't really delved into that too much. But to answer your question, there are two sides to this. One is that from the Western Bloc, they want the currently developing countries to reduce their carbon footprint, mainly India and China, because they believe that the current emissions that are going to be accounted for will be mostly from India and China. From the developing side, the narrative is the opposite, which is that we need time to reach the standards that you have reached, that is the Western Bloc. And so for that to happen, you need to allow us to invest a little bit more in fossil fuel usage before we can completely transition to green energy. And so this is where the idea of net neutrality and the carbon emissions target that each nation have been proposed at the COP, or the Conference of Parties, which is an annual conference that happens with all nations committing towards a climatic solution, a climate change solution. One is that India has promised that by 2070 we might reach the case of net neutrality. That is, how much ever emissions we are going to emit, we are going to take it back. That is sequestered. For US and other countries, it's somewhere around 2030 or 2040. So these time periods that differ do serve as a possible solution for many countries to actually reach the income or global standards while also growing in a more sustainable way.
So, in the defense of the Western Bloc, there is also a lot of technological advancement and leapfrogging that is going across the globe. So, are we sort of hiding behind saying that, okay, well, no, we need so much time? Or is there a sort of consensus, okay, let's use the latest technology available and sort of leapfrog some of these not so nice decisions that the West have made, and we can any such narratives sort of yeah.
I don't think there's a leapfrog. I think all countries are open to transitioning to a more greener form of production as well as a sustainable system. The only issue is of the actual technical know-how as well as availability of these resources. Uh, Currently, as we all know that green technologies or the electric technologies that are coming as possible solution to the existing ones are not economically viable. For instance, if you were to compare the cost of a individual house that runs on the electricity from solar versus the current system, it's much more cheaper to go with the current system, at least in India. Right? It's not
Right.
economically viable to move into a fully solar system because the cost of panels are really high and so on. So unless and until those costs have reached the standard where it is feasible for an individual household, we will not see that. Surely we are seeing that in electric vehicles that it is becoming more and more feasible for many households to switch. In the
Mhm.
US and the West, it is much more easier for them because the cost of an EV vehicle is on par with the cost of a petrol or gas vehicle. There's not much difference there. Right?
Right.
So it really comes down to the cost benefit analysis of these systems.
Right. Okay. Thank you, Kedar. Any other questions from any participants?
Uh, uh,
Okay, I think there are no more questions. So thank you so much, Dr. Kedar, for spending your time with us. I hope you and your areas are safe from all the rains and all the changes that are going around. So thank you so much. So we'll to the rest of the participants, we'll meet you all of you tomorrow at around 3:30. Tomorrow being the final day, we'll have two sessions, one by Shomya Chatterjee and by Shali. Thank you so much. Thank you, everyone.